So today we'll be looking at trigonometric review. So to begin with, an angle is said to be in standard position if the initial arm is on the x-axis and the angle goes from that x-axis to a terminal arm. When an angle is in standard position, we can actually represent this angle with a pair of coordinates, so a point on the grid. And as soon as we have the point, the x and the y, because it forms this right angle triangle, the r can be found using Pythagorean theorem, because the r would just be the square root of x squared plus y squared. And that will make it always positive. So if we wanted to find sine, sine is going to be opposite over hypotenuse, which looking at the x, y, and r, that would be y over r. Cosine of theta is adjacent over hypotenuse, which looking at our x, y, and r, the adjacent side is x, the hypotenuse is r, so x over r. And last but not least, tan is going to be opposite over adjacent, it's our TOA, and that would be y over x. So if we have a point to represent our angle, then we can find the three primary trig ratios, sine, cos, and tan. The cast rule helps us to know which trig ratio is positive in which quadrant. So it's cast because it is C-A-S-T, and whatever the letter is, that shows us which ratio is positive in that quadrant. So in the first quadrant here, it's the A quadrant. That means that all of them are positive. In the second quadrant, it's the S quadrant. That means that only sine is positive there. In the third quadrant, our T quadrant, tan is positive. And in the fourth quadrant, only cosine would be positive. Okay. You should also, from last year, remember special triangles. Whenever we talk about exact values, chances are we are talking about special triangles. And you also need to remember the graphs of sine and cosine. So there's my graph of sine. And here is my graph of cosine. Both the graphs have the same max and min values. The max value is 1, the min value is -1. And they have the same critical points along the x-axis. Critical points occur every 90 degrees. So they start at 0, then 90, then 180, then 270, then 360. And each of these critical points is either a max, a min, or it's on the midline, which means it's right in the middle. So there are our two scales, and we can see that the sine and cosine graph are actually really similar. Just sine starts at the midline and then it goes up, versus cosine starts at the maximum and then it goes down. Next we'll go through some terminology. So coterminal angles, that is angles in which at the standard position they share the same terminal arm. Okay, and coterminal angles are always going to be multiples of 360 degrees apart. So what that actually means on our grid here, if this was our terminal arm, and let's say it's a 45-degree angle, a coterminal angle is going to have the same terminal arm. So it's going to start at the x-axis and it's going to end at this terminal arm. In order to do that and be a different angle, it's going to do a full loop around, so a full 360 plus that extra 45. That's a coterminal angle. It could go around twice and then go to that. So it would be two 360s plus the 45. Or it could go the opposite direction, so it could go 45 minus 360, and that would also be a coterminal angle. You could minus another 360 degrees, and it would take you back to this same arm. So coterminal angles are called coterminal angles because they share the same terminal arm. So for example, 45 and 405 are coterminal angles because they're exactly 360 degrees apart. Okay, if I did 45 minus 360, I would also get another coterminal angle, and that would be negative 315 degrees. I could do 405 plus 360, and that would give me another coterminal angle, 765. Okay, I could add 360 again and again and again, and I would keep getting coterminal angles. Next, we have to deal with positive and negative angles. So positive angles are measured in the counterclockwise direction. So for example, 120, that is going to be in the second quadrant because the first quadrant ends at 90 and the second quadrant ends at 180, and 120 is between 180 and 90. So 120 would be about there, and that is in the second quadrant. Negative 30 degrees, because it's a negative angle, we measure it in the clockwise position. So we go down 30 degrees clockwise. So this right here is our negative 30 degrees. And that is found in quadrant 4. The last thing we have to look at is the related acute angle. So this is the angle that is measured from the terminal arm in standard position to the x-axis. And it's to the nearest x-axis. So for each of these, our related acute angle would be if we dropped to the nearest x-axis. So that red angle there would be our related acute angle. And I usually write that as O sub r, or theta sub r. And the angle there between 120 and 180 is 60 degrees. So the related acute angle is 60 degrees. Okay. For the angle here in the fourth quadrant, our related acute angle is the angle the terminal arm makes with the x-axis. In this case, our related acute angle would be 30 degrees. So here are our trig identities that we did in grade 11. Okay. These are the ones that I would expect you guys to be familiar with. We will be learning some new ones later on in the course when we enter our trig unit. Example 1 here. So we are given the point 2, negative 9, and it is on the terminal arm of an angle theta in standard position. Illustrate the angle and determine the exact values of sine, cosine, and tangent for the angle theta. Okay, so first we're going to plot the point 2, negative 9. 2, negative 1, 2. So there's negative 9 there. So the point 2, negative 9 would be about here. So drawing from the origin to the point 2, negative 9, that gives me the terminal arm for my angle. And my angle's in standard position, so the theta would go from the x-axis all the way around to that terminal arm. And now we want to find all these trig ratios. We want to figure out the exact value for sine theta, cos theta, and tan theta. And remember, sine, cos, and tan are written in terms of x, y, and r. We already know what x is. We already know what y is. So the last thing we actually need to solve for is our r. And that is just the square root of x squared plus y squared, which in this case would be the root of 85. And now since we know our x, y, and r, all we need to do is plug them in. So sine was y over r, so that's going to be negative 9 over root 85. Cosine, from the very beginning of this lesson, was x over r, so that'll be 2 over root 85. And tan was y over x, so it would be negative 9 over 2. Okay. And those are the exact values for the trig ratio. Had they asked us to find theta, then we could have solved for it by inversing either the sine, the cos, or the tan to isolate for theta, but they didn't ask us in this case. Okay. The next example here, they were asking us to find the exact value of these three trig ratios. So the first thing we're going to have to do is we're going to have to draw in where 225 degrees is. Okay. And that is going to be in our third quadrant, so it sits between 180 and 270 degrees. So it'll be right here. And to figure out what our related acute angle is, all we have to do is we have to figure out how far past 180 did 225 go. So we do 225 minus 180, and that gets us 45. So we know the related acute angle is a 45-degree angle. So we know we're going to use our 45-degree special triangle. Okay. And if it helps you, you can draw it in on the graph here as well. So I got all the sides there. X and Y would both be negative in this quadrant. And sine is just opposite over hypotenuse, so it would be negative 1 over root 2. Okay, and that makes sense since we are in the T quadrant. So only tan would have been positive in this quadrant. So next we find the cos of negative 300 degrees. So because it's negative, we're going to be moving in a clockwise position. And we're going a full 300 degrees, so just 60 degrees from a complete rotation. And that means this related acute angle, the angle it forms with the x-axis, is going to be 60 degrees. And once again, if it helps you, you can draw in the triangle here. Opposite to 60 degrees is root 3. Okay, so we're just transcribing our special triangle onto the axis here. And because it's in the first quadrant, everything is positive. So cosine of negative 300 is just going to be the adjacent over the hypotenuse. So 1 over 2. Next, we want to find the cotangent of 150. So first, drawing in 150 degrees. It's going to be in the second quadrant here. And the related acute angle would be 30 degrees, because that's how much would be left to get to the x-axis. So transcribing our 30-degree triangle here, opposite to 30 is 1, 2 is the hypotenuse, and root 3 is adjacent. And then in this quadrant, our x-axis is negative, our y-axis is positive. Now we need to remember that cotan is really just the reciprocal of tan. So tan theta was y over x. So that means that cotan of theta is just going to be the flipped version of this. So it's going to be x over y. So to find the cotan of 150, we're going to do the x, which is negative root 3, over the y, which is 1. The other way that you can think about this is you can think that tan is opposite over adjacent, so cotan is going to be adjacent over opposite. So for the next examples, you will have to go to the next video.